gentlemen, please welcome on stage Alessandro Puliti, CEO Saipem, Toby Rice, CEO EQT, Maria Sferruzza, Executive Director International Engineering, Construction and Solutions, Snam, Ty Smith, Chief Nuclear Officer, Paragon Energy, Moderator, Nasir Tibi, Anchor and Producer, Arabiya.
Thank you. Good evening, everyone. Good morning. It's still before noontime. Yeah. Allow me to quickly define the parameters of our panel discussion now. In the final communique of COP28 in Dubai 2 months ago, this sentence was included. Quote, transitional fuels can play a role in facilitating energy transition while ensuring energy security, unquote. This particular statement, ladies and gentlemen, is a tacit, official global nod towards natural gas. The Russian-Ukraine crisis and the price and policy signals that ensued have unleashed new upstream gas developments and a wave of investments into expanded regasification and liquefaction capacities. Baker Hughes believes liquefaction capacity alone would increase by 70% by the end of this decade. But despite this, things are not so straightforward for gas. Just a few days ago, the Biden administration has paused approvals for new LNG terminals indefinitely, affecting some 17 projects awaiting approval to proceed. Surely, natural gas is the cleanest burning hydrocarbon. It is abundant, it is versatile, it helps meet growing global demand for energy, and it's very able to partner with renewable energy sources. But gas still emits considerable amounts of CO2. And in some instances, LNG could be worse than coal due to production and infrastructure methane leakages. A key dilemma for investors undertaking large, capital-intensive gas supply projects is how to reconcile strong near-term demand growth with uncertain and possibly declining longer-term demand. So, can we ensure security of supply and at the same time make gas net zero? Is natural gas credible, or should we focus on other energy sources such as nuclear? Or would clean hydrogen be a panacea for the gas industry? These are the questions we're going to try to maybe answer here, and I'll start with you, Toby. Is gas a bridge fuel? Is it a destination fuel in a net zero world by the middle of this century?
Regardless if you call it a bridge fuel or a destination fuel, in any situation, gas is needed now, and a lot more natural gas is needed. We believe natural gas is going to be critical towards meeting the goals of the world. And the goals of the world need to be, I think, just expanded and solidified. Our goal is to lower global emissions and provide energy security to the world. And that is something that natural gas will help us accomplish. And you hear about what role the United States will play in this. To achieve global energy security and lower global emissions, the market is massive. On the global emissions front, to replace foreign coal, which is the biggest source of emissions, and COP mentioned that another point they said is they need to accelerate the reduction of coal use. LNG is going to be the answer there. It would require an additional 180 BCF a day of natural gas in the form of LNG to replace foreign coal. So that's almost 3 times larger than the LNG market today. And from an energy security perspective, let's not forget about the billions in this world that live on less electricity than it takes to run a fridge. To replace the biomass, which is a primary form of energy for the billions around the world, would require an additional 120 BCF a day of natural gas to replace it. So when you step back, this is a massive opportunity for us in natural gas to play this role. And how will America play a role here? You mentioned Biden's executive order they put out, and there's a popular talking point in DC, and that talking point is, oil and gas in America, you guys are complaining about regulations, but how hard can it be? You've got record amounts of oil and gas production, in the US. And while that's true, the question isn't how hard can it be? The question is that good enough? And you look at the world we're in today, rampant inflation, war in Ukraine, emissions are still skyrocketing, and energy security is crippled. Clearly, we need to be doing a lot more. And when you think about what we've accomplished in the US, despite these challenges, think about the amazing opportunities that we could bring to the world if we were supported and unleashed to bring the great work that we do to help solve the world's biggest problems.
Alessandro, is natural gas critical to the success of the energy transition, or can the world do without it in the longer term?
Okay, I will start my answer reminding ourselves that if you check on many applications are now available on gas utilization and various sources of energy utilization, if you look at Italy today, you will find out that to light up this room the way it is, this is done 60% on power generated from gas. And if you sum it up with the gas that we are using to heat up the room and heat up our houses here, you will find out that we cannot get rid from gas either immediately and not easily, and either easily. So gas is certainly part of the transition, but because it's the fuel of today and will be the fuel of tomorrow. And there are plenty of opportunities to reduce the carbon footprint of gas, to be the ideal fuel in the transition. So I tend to agree. To me, there is no contradiction between transition, destination. Gas is something that we have to use, and we needed to use it maybe better what we are doing it today. And I can tell you also that the gas is also ideal fuel when we come to hybrid power generation, to be combined between, for example, gas turbine with solar power and so on. The two things, they can go nicely together in helping reducing the CO2 emission, because this is the goal.
Yeah, ramping up and down with gas is easy with intermittency of renewables. Maria, in the past 2 years, to substitute for Russian piped gas, Europe imported an extra 70 BCM of LNG and brought in more FSRUs. It also signed 20-plus year LNG contract, which was unheard of for Europe at this time. Do you think LNG has solidified the role of gas in the energy mix for Europe for decades to come, or is this still uncertain?
Actually, I would agree with what has been said already, and the experience we had in the last 2 years with LNG strengthen the fact that we believe that gas is key today and will be key tomorrow, even in the sustainability journey to the energy mix that we are targeting globally and specifically in Europe. And I like to share a bit the history, right? Because LNG not only replaced a lot of the Russian production, bringing the import from 45% to 15% in 2 years of Russian gas, and moving LNG itself from 70% of total import to 37%, but also made Europe and Italy as well more conscious on how important is to diversify a source of supply for security, but also for affordability, and how diversification is going to be critical for the energy mix of tomorrow. And going back in a bit on the dynamics, right? Right after the unfortunate event of Russia and Ukraine, A lot of European countries, but Italy in particular, bought 2 FSRUs, as you say. One entered in operation after 10 months, bringing into the system additional 5 BCM of capacity. The other one, with the strong cooperation of Saipem, is going to be in operation at the beginning of this next year with additional 10 BCM of regasification capacity, bringing the overall regasification capacity in Italy at 28 BCM and creating a much more flexible system, right? Because the flexibility and the diversification of supply is going to be critical for today, looking at fossil fuel, but even more for tomorrow, looking at green molecules and different sources of energy. The flexibility lesson learned is something I like always to point out. LNG saved our security, I need to say, but at the same time, it has been possible because Europe, Italy, had also strong storage capability and a pretty extensive network, which made easy to connect the new terminal, regasification terminal, to the grid. Otherwise, it could have taken like 7 years to put those terminals in operation.
Not
right?
every country is fortunate enough to have this kind of gas infrastructure in place, just like in Italy. Tighe, the IEA puts nuclear at around 10% of the current global energy mix, and they expect that in the next 2 decades, this share will remain flat or maybe slightly decline because there's no material pickup in new nuclear projects in the current pipeline. In a net zero world, could nuclear displace gas for that base power load on the grid? Is nuclear and gas, compatible, complementary, or could they ultimately compete against each other?
Right, well, this is the right crowd to have to answer that question well, right? So I think one of the things that I took away from yesterday's talks was one of the hard truths that we're facing is it takes all things to make this transition. The huge transition in how we're producing energy in this world. And certainly gas and nuclear have operated complementarily for years, for decades with nuclear utilities. And so it's very complementary. We need gas. We have to rely on gas for the next decade, probably longer. There are technologies that can decarbonize the gas production. At the same time, that we need the right policies and the right investments in nuclear so that we have baseload capacity that is not relying on intermittent renewable technologies. We know that nuclear can produce 18 to 24 months of continuous electricity based on its fuel load. So it creates energy security just by having that much fuel at a nuclear reactor and able to operate for the long term. But it's also a fact that we have to face that nuclear has been difficult to construct, particularly in the United States. We suffer from being overregulated, but also we're not used to doing some of that work. So we need some help from international partners like Korea to come in and kind of reteach us how to make nuclear successful in some of those economic climates.
We're going to come back again to those cost delays and budget overruns for nuclear projects, but let's move on to the topic of methane. Alessandro, zero methane by 2030 from routine flaring and infrastructure leakages has been pledged by many oil and gas companies, many maybe here in the room as well, at COP28 in Dubai. Will the industry be able to deliver on that pledge, and how?
So certainly it is possible to deliver on that date. Technology is there, it's available. We are offering to many of our clients zero flaring solution for their plants, for their infrastructure, as well as we clearly have the possibility to control and immediately remediate to any kind of fugitive methane emissions. Those are the two sources that we need to that needs to be controlled. So I see the objective achievable. Technology is there. As a matter of fact, all the new engineering for all the new plants that we are designing nowadays is done on that basis, to have zero flaring or whatever maximum is, whatever the minimum possible for safety reasons.
But what about retrofitting the old?
Retrofitting the old, we are carrying out such kind of activities. We see many of the international oil and gas company that are investing on that in reducing flaring. And then there is also not only a climate goal as an incentive to do such action, but we also have to remind that such actions, they are leading to more sales gas at the end of the day. So there is a double drive on that action. So I believe that is just matter of will. There is capacity on the contractor side. There is the willingness of the oil and gas producer. So I don't see why we should not achieve the target.
Maria, how important is to reduce methane emissions today for the oil and gas industry?
It's key. As we said before, if natural gas will be part of the energy mix of tomorrow, notwithstanding today is not among the fossil fuel the major producer of methane emission, because oil and coal produce more, but still it delivers about 37 million tons per year. So it's critical. What is important, Alessandro mentioned that there are many technologies available. You need to tailor-made to the different part of the oil and gas value chain. Because if we look to transport obviously has the challenge, but is a bit lower than upstream. Upstream generate a different amount, but still it is key. It is key to us, for example, to meet our 2050 net zero target together with CO2 emission abatement. And we do technically three main things. Instrumentation upgrade, leak and repair program, and recompression. Recompression is the other key element that we have not developed 100%, but we are going to exercise in a more extensive way in the near future.
Toby, does the industry need clearer and stronger government regulations on methane emissions spanning the whole value chain? Maybe in the US context, the Biden administration has just introduced 2 months ago a new rule on methane. That's in addition to the LNG terminal pause. So what's your take on that?
So the ultimate goal is to ensure that the public understands that methane emissions are under control. Regulations will play one piece in that, but that's not going to be the total story. We need to take aggressive actions to eliminate methane emissions, because this is the biggest environmental concern on our industry today, and this concern is translating to bad policy, like what we just saw on Friday with the pause in LNG. But the good news is this, and this is what I said to Secretary Granholm about 24 months ago. If you're concerned about methane emissions, good. Keep the bullseye there, because we're going to knock methane emissions out of the park. And we've been taking aggressive actions in this industry, and people are stepping up and putting their money where their mouth is. At COP, the Oil and Gas Decarbonization Charter was a commitment from oil and gas producers to sign up to be near zero methane emissions by 2030, net zero scope 1 and 2 by 2050. These are bold actions that people are taking, and over 40% of the world's oil and gas producers, signed up to that pledge, including EQT. And this is something that I think people need to really appreciate the work that's going on here, because this is something that we can control. And I'll just show you a couple things that we've done at EQT. Lorenzo talked about it, efficiency. That was one of the biggest things that we've seen lowering our carbon footprint, is just hardcore operational efficiency. As we've moved to large-scale operations, we've seen a dramatic increase in the efficiency. operationally, and that translates directly to the efficiency we see on the greenhouse gas side of things. Then we've moved to electrifying the oil field, which is an awesome trend that's taking place in this industry, replacing diesel equipment with electric equipment, and the electric frac fleets are a great example. We utilize 100% electric frac fleets at EQT. The third thing is really pinpointing the sources of methane emissions and eliminating those. Whether that's oil producers getting rid of the flares, or for gas producers like EQT, our biggest source of emissions is a pneumatic device. It's a piece of equipment put on our locations to help move fluids. And the good news is that we have alternative pieces of equipment that we can use to replace that. Now at EQT, we had over 9,000 of these devices spread across our footprint. And we're the largest producer of natural gas in the country, just to give people a sense of the asset base we have. If we were a country, we'd be the 12th largest producer in the world. In less than 18 months, we replaced every single device. The impact of that was tremendous. That one thing lowered our methane emissions by 70%. We did it in less than 18 months. We did it for a cost of less than $10 per ton. So it's fast, it's effective, and it's incredibly impactful. And guess what? These opportunities do not just exist within EQT, they exist within all of industry. We've put a white paper on our website so that others can follow these steps. People need to also know when it comes to ESG, somebody comes up with a great solution. ESG ideas are open source in this industry, and we are happy to share all of those. That's what we're doing organically, operationally, to reduce the carbon footprint. The next step for us is to bring transparency. The gas certifications that are taking place are the third-party environmental auditors that come in to certify and say what you're doing is actually happening. That's great. We're taking to the skies, going outside of our operations and looking at the entire basin. We've established a coalition of operators to do aerial methane monitoring, where we are surveying the entire Appalachia Basin, which is one of the largest gas fields in the world. And just to give you perspective how big a deal this is, we're going to be monitoring an area the size of France. Like, we take this very seriously. And then lastly, this gas does not just stay in this basin, it goes across the country to all parts of the world. And so to showcase the carbon intensity across the full cycle value chain, we've partnered with a company called Context Labs, and some other large industry players are going to be working with Context Labs to generate a full cycle carbon intensity score from the time the gas comes out of the ground, through the pipelines, down to the downstream facility, and to the doorstep of Europe or Asia. We will be able to produce a verified carbon intensity score. These are tangible steps that are taking place right now, and in time you will see that we are knocking methane emissions out of the park. And the reason it's important is this, and I'll wrap up with this very quickly. We cannot let the conversation be focused on, we cannot let the emissions associated with making our product overshadow the emission reduction benefits when people use our product. And as an example, at EQT, to run our entire program, it requires a carbon footprint of about 350,000 tons. Now that's the methane emissions, that's what people are saying we should shut down. But that operations will produce amount of natural gas. When put on the world stage to replace foreign coal, will have an emissions reduction benefit of over 180 million tons. It's the greatest deal in climate. And so to get people focused on the emission reduction benefits, we're going net zero on scope 1 and 2 and focus the world where it matters.
So it's a relative thing when you look at it, right? So, Ty, moving on to nuclear back again. According to some sources, nuclear power production declined in 2022 by 4% to a 4-decade low. Cost overruns, delays have plagued the nuclear industry for decades. So how can we discuss here the future role or a future expanded role of nuclear when the industry is facing these challenges? How can the industry grapple with these?
Well, I think we have some interesting partnerships that have come out of the new technology base. So when we think about small modular reactors that produce power below 300 megawatts, down to 5 megawatts in certain circumstances, those companies are partnering, instead of partnering with electric utilities, who in the United States haven't built a lot of large infrastructure projects in quite some time. They're not particularly great at that. They're partnering with companies like Dow. So X-Energy has partnered with Dow at the Seadrift plant to retrofit the existing gas turbines with nuclear. And one of the great things about that partnership is that Dow is bringing experience in large infrastructure projects globally to reteach the U.S. nuclear industry how to build things again and how to work with construction partners to make things more effective. One of the things we're doing with Reuter-Stokes, which is a part of Baker Hughes, is working alongside those reactor vendors and figuring out the efficiencies that we can bring to our manufacturing processes, taking advantage of our own quality assurance programs to reduce the burden on the end user and the end customer for those same technologies. So that innovation is happening rapidly in our industry. We have NuScale as another partner of ours, the long-term customer. They are partnered with data centers to try to figure out how to power the data centers with nuclear. Those people that are building data centers have a wide variety of experience. We need to learn from that, bring that experience into the nuclear industry, and do what we do best, which is understand how to fuel reactors, operate them safely, and then get out of the way and let other people build them for us.
All right, sounds like a plan. Alessandro, further on decarbonization, which Toby just touched upon a little while ago, what are the possible solutions to address the carbon intensity of LNG, whether in the feed gas production or in liquefaction or even in shipping?
So we at Saipem, we've been developed solution to reduce emission and to improve efficiency of the LNG chain. Particularly, we applied, and we did apply for more than one client, a solution to reutilize and reuse in full the boil of gas, so that this is not wasted and it is reutilized and neither flared or vented. And so I believe that it's a key area where we improve the efficiency, because this matter goes under improving efficiency of the entire LNG. So again, technologies are there. We can minimize the footprint of LNG. We did several of these actions, and clients are happy to see this design applied. Same goes for the shipping. We through our Moss Maritime company in Norway, we hold the patent for the certain kind of LNG carriers, and they are all designed to minimize the utilization of gas while sailing. So that's a bit the key. LNG is essential because it has the flexibility, and so we cannot get away out of LNG. And to be honest, LNG demonstrated its value right after the Ukrainian crisis. So without LNG, as Maria said before, we could not really cope. So LNG is essential in the market of gas, moving gas around the world, and this is also, but can be done reducing the footprint.
Mm-hmm. Maria, big plans in the pipeline for carbon capture projects in the coming years, but what is Snam doing on the technology side of CCS? Could that technology be the key for the future of gas?
So, yeah, we have started to be involved in CCS in the last couple of years, in particular because, as we know, CCS is critical for the so-called hard-to-abate industries. That in Italy means 5% of the GDP and 5% of the employed base of people. So for us, it's mandatory. We are working with ENI, right, from a technology perspective on a specific project For Southwest Europe, we are creating an entire CCS value chain to decarbonize France and Italy, which is an anchor on this CCS hub in Ravenna, north of Italy, on the Adriatic side of the country. And we are leveraging our expertise in storage and transport for two main reasons. Because this project have the challenge of the economic viability. We believe that technology can be developed. Baker itself is ahead in capturing technology, but the reality is that you need to have the right business model that make it economically viable. And one of the key things is the repurposing of the infrastructure. So in Ravenna, for example, while Eni reuse depleting fields, which is the first big step. On the other side, we are maximizing the repurposing of existing pipeline infrastructure. And this will help, together with the change in the market of the price of the CO2, to make this project affordable. So I think technology is an element, but the entire system is the thing we need to target to make it affordable.
Okay, so we've got less than 10 minutes left, and we need to touch upon hydrogen as well. So, Toby, is hydrogen the most scalable form of decarbonized gas? How important is this as a low-carbon solution for the future?
So, when we think about our energy transition plan for the world, step one is transition the world from coal to gas. And step two is transition gas to a zero carbon energy solution. Hydrogen will be one of those pathways. Hydrogen definitely has some challenges, specifically the infrastructure needed to support the hydrogen. But the good news is this: when we build that gas economy to support the weight of the world in the future, that infrastructure to move those molecules will make sure that that infrastructure is hydrogen ready. This is a really great example of how our industry can set the table for the zero carbon energy solutions tomorrow. So the argument that we should not be building more pipelines, which in the United States is a very big challenge, it's kind of ridiculous. It takes an act of Congress in the US to get a pipeline built. But people need to understand that these pipelines will be setting the table. They will be lowering the hurdle for zero carbon energy solutions in the future. We should be embracing more hydrocarbon infrastructure today. But the thing that gets us most excited, we think the most feasible path to producing zero carbon natural gas is going to come in the form of carbon capture. This is something that is ready to roll right now. We just have not had the incentives to really push carbon capture underground, aside from maybe some EOR applications. That's all changed with 45Q. Now we have the incentives to want to put more CO2 underground. And the missing piece of the puzzle, it's not really the desire, that's checked. It's getting a pure stream of CO2. That's been very difficult. Well, that's changing. Net power and that equipment that's going to take natural gas and transform it into a zero carbon electricity solution is also going to give us the pure stream of CO2. That's a technology that Baker is building. And so us as industry, we need to get ready to harness that pure stream of CO2. And where are we going to put it? You know, we can go through and crank up the exploration teams to find those reservoirs. Guess what? We've got those skill set in spades, but we've also got existing assets. And think about this. In the United States, we produce 13 million barrels of oil. Alongside of that oil production is about 40 million barrels of water. So every day in the United States, we are creating over 50 million barrels of space for something else, like CO2. And when you step back and you realize that that has been going on for decades and decades, the last 100 years of oil and gas production in America has set the table for the next 100 years of zero carbon energy consumption. Definitely the focus is to be CO2 ready.
Yes.
So we need to harden our infrastructure and make sure that we're ready to receive this next, I think, wave of innovation in this industry.
Maria, how compatible is hydrogen with current gas infrastructure, you think? Is it costly?
It is.
Yeah.
You ask to the major European TSO, we cannot say it is not. So it's not only about building a new infrastructure, hydrogen ready, but validate the possibility to flow hydrogen 100% in existing infrastructure. And actually, we have done all the tests, and so at least the Italian infrastructure is ready to get 100% of hydrogen. And on this principle, and we are building, because in Italy we are expanding the pipeline network, mainly because of the gas emergency. As we were mentioning before, the gas flow has been reverted. Before it was coming from the north, now we have more volume from the south. That's why we are strengthening the pipeline with additional 400 kilometers will be on stream in a couple of years, all hydrogen ready, and habilitating the possibility to have natural gas and hydrogen at the same time flowing from the south to the north in the near future. So based on this concept, repurposing of existing and building hydrogen-ready infrastructure, we are working with the major European TSO on the so-called South H2 corridor, which has the ambition to connect North Africa, so including the pipeline which connects Tunisia to Italy, and North Africa to Central Europe, crossing the entire Italian corridor. It's going to be about actually over 3,000 kilometers of pipeline, of which 70% will come from repurposed assets from our existing natural gas grid, and 30% will be rebuilt. Data said that if you repurpose, you're gonna pay 1/3 less than new built.
Interesting. Alessandro, do you foresee low-carbon ammonia to be the leading end-use sector of clean hydrogen, both as carrier and as a direct fuel?
We see a very important future for low-carbon ammonia, not only looking forward to a direction to get hydrogen, but also to utilize the gas, not as a fuel, but as raw material to produce fertilizer for the agriculture. We should not forget that by the end of the century, we may be on this earth 2 billion more than we are, and we need all to be fed, and agricultural is essential. So ammonia, we see it now, today, a great request on the market, great demand for low-carbon ammonia plants. Actually, we are building one in Australia, and this is the most advanced, one of the most advanced, that has really very minimal CO2 emission associated. And then, if you then capture that even low emission associated, then you come really to a perfect blue ammonia that can then enter into the cycle of the hydrogen. Certainly ammonia has the best way to transport on long distance hydrogen, because it can be loaded on ships. And so on the very long term, this can become the real carrier for hydrogen, and then to be utilized wherever is required. But in all the discussion we have had today up to now, we've only discussed gas as a fuel, but gas is also a raw material. We should not forget it.
Absolutely. Tighe, how well suited is the nuclear industry to play a significant role in producing clean hydrogen? And could utilities, in order to maintain a stable power production, swing its production in between power and producing clean hydrogen?
Well, one of the benefits of nuclear technology is that we produce high temperature gases or steam, which you need, and of course electricity, which powers electrolyzers. So it's a very efficient way to produce hydrogen natively. And so what we see are nuclear utilities looking at what they're going to do to balance their load. Nuclear power plants run best at 100% capacity all the time. So we're seeing nuclear utilities now looking at how they're going to switch their operations from the production of electricity to the production of hydrogen. That's something that all of the utilities are looking at. There's 2 pilot plants happening now in the United States that I think is changing how nuclear utilities are thinking about their pricing models for electricity, how they're thinking about building out their infrastructure, and then also it's an important part of the use case when we get into advanced reactors and small modular reactors, particularly for industrial applications where a user may buy this asset, it'll power itself for 20 years in certain circumstances. So you don't always need electricity at your site. You can balance that with the production of hydrogen, either for your own use or to sell it onto the market, much like we sell electricity today. So it's an excellent addition to the capacity for creating electricity, and it helps our utility customers to balance their portfolio and take advantage of the recent IRA tax incentives around hydrogen.
Yeah. Yep. Well, we're right on the clock now. That's all the time we have. I would like to thank you, Maria, Toby, Alessandro, and Tighe. A round of applause for the final panel of this year's annual meeting. Thank you. Thank you all.